Hi guys, welcome back to my YouTube channel, Let's Crack Real Math. My name is Viraaj, and in this video we'll be having a look at translation under the topic transformation. So before I begin the video, please do not forget to perform an LSS, that is like, share and subscribe, and without further ado, let's get started. So before I go into some examples, let's see what I mean by translation. So in layman terms, translation in mathematics obviously is simply changing the position of a shape via the horizontal and vertical axes. Now whenever you are told to translate a shape, you will be given a vector form where the top number, let's say x, and the bottom number, let's say y. Now the first number, the top number x, simply means movement of that shape horizontally. So if the x is positive, that means the shape would move to the right, and if the coefficient of x was minus, that means the shape or the polygon or whatever it is will move to the left. And the bottom number, integer over here, in this case y, but I'm just using y as an example. If this is positive, that means the image will go up, and if it's negative, then that means it will go down. Now the amount of spaces it goes to the right or left, or the amount of spaces it goes down or up, is defined by the number. So suppose I have 3 and 8. This means that my image, if I were to translate it using this vector form, the image would now go 3 units to the right and then 8 units above. Likewise, if this was minus 8, then it would have been 3 units to the right and 8 units down. And if it was minus 3 and minus 8, then it would have been 3 units to the left because it's minus, and 8 units down because it's also minus. So let's have a look at our first example. So let's just zoom out a bit. Okay, so this example says the following graph shows two shapes labeled A and B. Okay, good to know. Work out the vector, okay, that translates shape A to shape B. That's question A. And question B is work out the vector that translates shape B to shape A. So they've given us the two different shapes, and they want us to find the vector that's satisfying them. So let's do A first, part A. Part A says to work out the vector that translates shape A onto shape B, to shape B. So that means what vector would satisfy A to now becoming B. So we have to see what happened to A in order for it to become B. We can see that it obviously moved down. We can see it moved down to somewhere here, and obviously it moved to the right. Now when we are writing it in terms of vector form, again we know that the top number, x, is the one that shows the horizontal movement, and the y, the bottom number, is the one that shows the vertical movement. So let's do the horizontal movement first. So the best way to go about doing these sorts of questions is when you're trying to find the vector form, is to pick a corner or an edge or a vertex of the shape and focus that shape onto the same edge on the translated shape. So from here to here. So in order for that to happen, we went 1, 2, 3, 4, 5, 6, 7. Okay, I find 7, 8, 9, 10, 11, I think. Let me just do that again real quick. Okay, so we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. So we had to go 11 units to the right, so automatically that means top number is 11, and now we need to see how many units we went down. So we have to go 1, 2, 3, 4, 5, 6, 7. 7 units down. So your answer to that for part A, for the vector that translates shape A onto shape B, is 11 and then 7 at the bottom. You could have looked at this the other way around. You could have first seen how many spaces it went down and then see how many spaces it went to the right, but then you need to always make sure that the horizontal movement is on the top, and that's why I did that one first, because that makes it a lot more easier for me to remember. So on to part B. It now says work out the vector that translates shape B to shape A. So we're going the opposite way around. So let's see how this will go. Okay, sorry, I think this is 11 minus 7. Yep, 11 minus 7. Sorry guys, because it goes 11 to the right, yes, and then it goes 7 to the bottom. So yeah, 11 minus 7. So B. So again, we take the same edge. Of course, you guys, you can take any edge. You can take this one, and this one. But I will take this one solely because we did it for the first part of the question. So let's go from B to A. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 units to the left, and you go 1, 2, 3, 4, 5, 6, 7 units up. So this in vector form would now be minus 11. Why minus? Because you're going to the left, and if you're going to the left, it's minus and over 7, because if you are going up, it's positive, and if you are going down, it's negative. Now I could have done this question in a much easier way. I would have known that if A to B is 11 minus 7, I would have known that B to A would have just been the opposite of this with the change in sign rather. So I know that the positive over here would have became minus, which eventually did happen, and the minus over here will eventually become positive, which did happen over here. But since we are explaining this question, I think it's always safe to confirm it doing it manually. On to the next example. This one says to translate the following shape by the vector 4, minus 4. So I know that when it says 4 on top, that means it goes 4 units to the right, 4 units to the right, and when it's minus 4 at the bottom, I know this means it's going 4 units down. So when you are given the vector and you have to translate the shape, again the best thing is to pick a vertex or edge or a corner, and you could start with them and then do the rest. So let's start with this one. So it tells me to go 4 units to the right, so 1, 2, 3, 4, and then 4 units down. So 1, 2, 3, 4, somewhere here. Let me just get rid of all this so it's not confusing. Somewhere there. Now let's have a look at this corner here. So 4 units to the right, 1, 2, 3, 4. 4 units down, 1, 2, 3, 4. So somewhere there. Now let's take this one again, 4 units. Now as you can see, it's not exactly at a point, so we might have to just do a little estimate here. So let's say this is 1, this is 2, this is 3, this is 4, and then this is 1 down, 2 down, 3 down, 4 down, somewhere there. Now let's take this point over here. So again, not going to be most accurate, but 1, 2, 3, 4 to the right, and then 1, 2, 3, 4, somewhere there. And last but not least, this edge or point over there. Again, this would be 1, 2, 3, 4, and then take it down 4 units. This would be somewhere here. So 1, 2, 3, 4, somewhere there. And now all remains is for you to connect the points together. So this would be something like that. Should go here. Let's just do that again. This would go here. This would come down here. And this would go there. Again, not the most accurate, but I think it's more than enough for us to get the idea. And that is the answer for that question. Please do take notes of when you need to go to the right and left. You go to the left when it's minus, you go to the right when it's positive, and then you go down when it's minus, and you go up when it's positive. On to the next example. So this smaller. Right, so this one tells me the following grid shows two shapes labeled A and B. Okay, good to know. Which vector transforms shape A to shape B? So we need to get the vector which translates A to B. So again, I use my method. Take one end and see how it goes over to the other end. So going to the right, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units to the right, and then 1, 2, 3, 4 units above. So we know that the vector is nothing but 11. Why 11? Because it goes to the right and it's positive. And then 4. Why 4? Because it's also positive and it will go up. Now I only took 1 point, but you could take another point just to be sure you're correct. So let's just take this point. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then you go up 1, 2, 3, 4. Yes, so the first translation is correct. So the vector is obviously correct. So let's look at part B. Part B says translate shape B by the vector -1, -2. So that means when it says -1, -2, I know that we're going to 1 unit to the left and 2 units down. So again, let's take 1 point. Let's start with this. We go 1 unit to the left, that's somewhere here, 2 units down. So 1 and 2. Somewhere there. Let's take this point here. We go 1 unit to the left, and then 2 units down. So 1, 2, somewhere there. Okay, let's take this point now. We go 1 unit to the left, so somewhere there. 1 and then 2 units down. 1, 2, somewhere there. Let's take this one. We go 1 unit to the left. That's 1 there, and then 2 units down. 1, 2. Somewhere there. Again, not the most accurate, but this is a rough estimate. And from here we go 1 into the left, and then 1, 2 down there. So this is how our shape would look like, something like this, 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 this. Now it may look a bit wrong because I am doing it on a laptop, but this is how it's meant to be. Maybe this line could be a little more towards this end here, but yeah, I mean, I think it's more than enough to get an idea of maybe something like this. Yep, so that looks like is the answer for that question. So that brings us to the end of this video. Thank you for watching, guys. Hopefully you enjoyed it. please do perform an LSS, that is like, share and subscribe. And also a shout out to YouTube channel JB Production with a C. Some great content there, you guys should definitely check it out. Thank you for watching. Have a nice one, guys.